Welcome. Today I am going to be going over the ideal gas law and um, trying to derive a formula from the ideal gas law. So what is the ideal gas law? The ideal gas law is PV equals nRT, essentially where P is your pressure measured in atmosphere, volume is measured in liters, and is just measured in moles, R is your constant. You have to note that there are two values for R, one that uses atmosphere and the other one uses joules for energy. When you are dealing with a gas, you want to remember that you want to use the one with atmospheres, okay? And then your temperature is just measured in kelvins. So I have this question set up on the board, um, and it is a system where a gas has a density of 5.75 grams per liter at STP. Okay, remember STP is a standard temperature pressure, which just means the temperature is 0 Celsius, which is just 273 Kelvin. It is not 25. That will be, 25 degrees Celsius will be room temperature. This is standard temperature pressure. So it's just 0, it's freezing cold. Then you have pressure. Pressure is just 1 atmosphere, okay? Very easy. Now, how to go from PV equals nRT to molecular weight? What the heck? What do I do? I'm so lost. You write PV equals nRT. I'll get it. Now, you have to realize that the N in nRT, this relates to the N comes from the mass over molecular weight because the units of mass are grams and the units of molecular weight are just grams per mole. So when these two cancel out, you're left with N. So N equals N. That's where you get this. Okay? So if I realize that this is the same thing, then I can surely substitute this variable on N. Okay? That's what I want to do. So PV equals this fraction. Um, Actually, I'm going to move this RT over. You can keep it where it is, but just so you can see it clearer. RT, and I just substitute for N, which is just mass over molecular weight. Okay. My next step will be getting rid of the fraction. I'm not comfortable with that fraction there. I want to see this expression a lot clearer. So, what do? I divide molecular weight on both sides, like so, and I'm gonna get molecular weight times PV equals RT times, and don't forget about the M, okay? Um, and then from here, you're like, oh, I see it. I can isolate for molecular weight, just dividing, right? So that's exactly what you're going to do. You're going to get you're going to get molecular weight equals RT times M over PV. Now, you have to realize another vital thing. M over V is density. This is the expression for density. So you can rewrite it again. One second. So you rewrite it again. Molecular weight um, equals RT over P times the symbol for density, which is rho. Okay, times rho. And this is your expression. Um, so the concepts here are okay. Concepts concepts that you must get very, very comfortable with. It's PV equals nRT. It has to do also with moles equals mass over molecular weight. And lastly, the density formula, which is rho equals mass over uh, volume. Okay? And that is pretty much it. This, when you do this, you are going to get uh, grams over mole. I won't put the numbers, we'll do it by yourself, but I will write the units so you see that they cancel out. Okay. Did I leave? Okay, I'm back, sorry. Um, so if I put the unit, it'll be uh, liters times atmosphere over mole times Kelvin times the units for density for rho, which will be grams over grams over liter. And all of this is over by pressure. Pressure is in atmosphere. So I hope that you are sort of seeing it. If you see that this is on top, this is on the bottom, just cancel it out. This is at the top, this is at the bottom for atmosphere, you cancel it out. And then Kelvin, this is the top, this is at the bottom, you cancel it out. So then you're left with what? You're left with grams at the top and moles at the bottom. And you know that grams over mole equals molecular weight. And that's how you solve this problem. I hope that it was helpful and yeah.